Okay, so let's start by looking at similar triangles. Two triangles are similar if they have the same shape, equal angles, and the corresponding lengths of the sides are in the same ratio. But really, look, if it's simply put, really, two triangles are similar if two angles in one triangle equals two angles in the other. So once this happens, once two angles in one are equals two angles in the other, then they're similar, and all the rest of this will hold true. Okay, so here's two triangles here, ABC, and triangle DEF, and you can see that although they're different size, they are the same shape, and they have three angles the same, and they're the sides, the corresponding sides. This side corresponds to this because it's opposite that angle here. This side corresponds to this side because opposite the same angle there, and finally DF corresponds to this side because it's opposite the same angle in both triangles. They're opposite the same angles in both triangles, and those corresponding sides, the lengths are in the same ratio. Okay, so we can also say about these two triangles that triangle ABC and DEF have equal angles, and another way of saying that is that they're equiangular. Okay, so all the angles in the triangles in one triangle are equal to all the angles in the other, or they're similar, which is where we started off with similar triangles. Okay, and just to note, as mentioned there, that side BC corresponds to EF, and that's because they both face this angle here. Okay, and AB corresponds to DE, and that's because DE here, because they both face there, and so on. We mentioned that earlier anyway. Okay, so now we look at a very important theorem associated with similar triangles, and that theorem says that if two triangles are similar, then their sides are proportional. So AB divided by DE. So if I have two triangles, this is A, B, C, D, E, F, then this side divided by this side is equal to this side divided by its corresponding side, which is equal to this side, this side divided by its corresponding side there, which is what the theorem says. Okay, and the opposite or the converse of this theorem is that if two sides of two triangles are proportional in order, then those triangles must be similar. But this is a very important kind of formula that we're going to use. We're basically going to end up, we're going to have two triangles, and more than likely we'll know three sides, and we'll look for a fourth, and we can just hive off this part of the formula to use it, as you'll see in a couple of examples. So here we go. Here's an example. We have two triangles here. We have ABC. We know this angle is and DEF, sorry, and this angle is the same as this. The one dot here represents one dot there. They're both the same. Two dots here represents those two angles are the same as well. Okay, and because there's more than two angles the same, well, once there's two angles the same, the third angle is going to be the same anyway because they all add up to 180. But anyway, once we have two angles the same, we know that they're similar triangles, so we'll know that the sides are also in proportion to each other. So there's the corresponding side. A, B, and D, E correspond. BC and EF correspond, and A and AC and DF correspond, because remember, why does AC and DF correspond? Well, AC is opposite this single dot angle, and DF is opposite this single dot angle. Okay, so we're asked to find DE, the length of DE, and the length of, DE is here, and the length of DF. So this and then this. Okay. So here is our formula that links up the corresponding sides in a ratio. So AB from one triangle over its corresponding side in the other is equal to BC in the first triangle over its corresponding side in the other is equal to AC in one triangle over its corresponding side in the other. Okay. Now, we know we're given AB, and we are looking for DE, we're given BC, and we're given EF. So we just have to use this part of the equation. We can just use the first two terms. So AB is 4, divided by DE equals 6, BC divided by EF, which is 9. So cross multiply then, 4 times 9 is equal to 6 times DE. So 4 times 9 is 30, so 6 times DE is equal to 36. So divide both sides by 6, and you get the fact that DE is equal to 6. And then we want to find DF. So we use the fact that AC over DF is equal to BC over EF. So really we're just taking this part of that ratio equation. So we know AC is 5, we know BC is 6, and EF is 9. And we're looking to find DF, so you cross multiply 9 fives is equal to 6 times DF, so 45 is equal to 6 DF. Divide both sides by 6. 45 divided by 6 is 7.5. 6 DF divided by 6 is DF. Okay, second example then. Show that triangle ABC is similar to triangle EFG. Okay, and then find FG. Okay, so first of all, if we find what this angle ACB is equal to, and this angle FEG, remember now this symbol here is for angle, and sometimes we'll put those two lines either side of that whole notation just so that it's the size of the angle, and sometimes I'll just leave it out. But anyway, we'll just say the size of the angle ACB must be equal to 180 minus these two, because 3 of them should add up to 180, so it's 57. And FEG must be equal to 180 minus these two, so it's 43. So there must be similar triangles then, because if this is 57 and this is 43, then these two triangles have 3 angles the same, not only 2 angles the same, but 3 angles the same. So they must be similar. Okay. And then we need to find FG. So in our two triangles then, BC is a side opposite 43, the angle 43. So that must correspond with FG here, because that's opposite the angle that's 43. So the corresponding sides. Okay, so BC corresponds to FG, but we're given EG, so we know what EG is. It's 15. So we can just, and we know that corresponds to AC, we also know that as well. So we can just use AC over EG, because we know both of those, is equal to BC, and we know that over FG, which we're looking for. So 6 over 15 is equal to 5 over FG. So cross multiply then, 6 times FG is equal to 5 times 15 is 75. So if you divide both sides by 6, you get FG is equal to 75 over 6 is 12.5 centimeters. Now let's look at another theorem here to do with transversals and triangles. Okay, let's start with the theorem anyway. If 3 parallel lines cut off equal segments on some transversal line, then they will cut off equal segments on any other transversal. And what that's saying is, if we've 3 parallel lines, L, M, and N, and we strike through this transversal P, and if that transversal striking through is cut into these 2 equal segments here, AB and BC, then striking any other transversal through the 3 parallel lines will result in equal segments of the transversal as well, D, E, and EF. So in other words, if I was to put those out here again, and I was to strike a transversal just like that, then I know that this side should be equal in length to that. Doesn't look it there, but it should and would be. Okay. Okay, so here's an example then. L, M, and N cut equal intercepts of 9 centimeters from transversal P. So this is 9 and this is 9. Okay, from there to there is 9 and there to there is 9. If Q is another transversal that strikes through, find the value of x. Okay, but when Q strikes through, it creates a distance here of 12, but we know from the theorem that if this is 12, then this must cut an equal length equal to 12. Okay, so if we're to find x, then we simply say, well, x plus 5 must be equal to 12, so x is equal to 7. Okay, 7 plus 5 is 12, that's what we have there. Okay, so be careful with this theorem. It doesn't say that if the parallel lines cut the transversal and create two equal lengths of 9, that doesn't mean that every other transversal will be cut into 9. Only if the transversal is parallel. If the next transversal is parallel to the original one, will it make an equal length? Okay, so this one cuts it into two lengths. They're equal. They're 9. But the next one, this one here, it's at a different angle. That cuts the segments into two equal segments of 12. So this is 12, and that's 12 as well. Okay, now another theorem: the line parallel to the side of a triangle. A line drawn parallel to one side of a triangle divides the other two sides in the same ratio. So here's a line drawn parallel to this side of the triangle as dividing these two sides into the same ratios. And there's three different ratios going on here. AX over XB is equal to AY over YC, or all of AB over AX is the same as all of AC over AY. Or the last one here, all of AB over XB is the same as all of AC over YC. So the three different ratios we'll use in the next video.